Welcome to How to Succeed in ECE Without Really Trying. I'm Dr. Linda DeBrenner, and in this video I'm going to review some simple, useful op-amp designs. Recall that for op-amp circuits with negative feedback, we can make several assumptions.
First of all, that the voltage at the inverting terminal is equal to the voltage at the non-inverting terminal. We say that as V minus is equal to V plus. Also, we can assume that IN is equal to 0 at each input terminal. So the input current to and going into that op-amp is always going to be 0. To analyze these circuits, what we want to do is just use nodal analysis to find the transfer function.
There are several classic circuits, and many other practical circuits you see will be variations of these.
We went through this before and we calculated the gain to be minus RF over R. Okay, remember that the input voltage is going to be here and it's typically time varying. Okay, we usually just write it like this. And the output voltage will be given here. So I have to tell you what the input and output voltage are, but if we have V out here and V source here, or V in, then we can determine the gain. It's inverting, you can tell from the gain expression because of the minus sign in front of the quantity. Now there are some guidelines for how do you choose the values for R, F, and R. Typically, I would say keep them in the range of k ohms. Don't go too big, don't go too small. If you're in a situation where you have to choose them carefully, you will want to do a little bit more research. Here's an example of a non-inverting amplifier. Okay. Again, we're going to assume that V plus is equal to V minus. Okay. We'll also assume that the input current going into the op-amp is 0 for both those terminals. So we do nodal analysis at this node, solve the circuit, and we can find the gain is equal to 1 plus RF over R when we're, again, computing the gain V out over VS. I guess in this case, it actually says VN. Sorry about the typo. Just make the circuits match. Okay, so how did I do that? What I did was I did nodal analysis at this node, okay, wrote the equations and solved for V out over VN. There is one trick you might want to remember. The current through this resistor is going to be 0 because the input current is 0, and so the voltage V plus is going to be equal to the voltage VN. Okay, we went through that before, but just a reminder there. Again, we have a current going from here in is 0, but there is current flow here and current flow here. Okay, and I'm not being specific about the directions. Okay, the third kind of classic amplifier we've looked at is the isolating amplifier. It's a special case of a non-inverting amplifier. What we do is instead of having a feedback resistor here, we actually just put a connection. So that means that feedback resistor is 0. And when we do that, we get V out over Vn is equal to 1. So that means that V out is equal to Vn. Sometimes we call this a source follower. Sometimes we call it an isolating amplifier. These are all names for the same thing. The purpose here is not to change the gain, since it's 1, but it is instead to isolate the output from the input electrically. So a lot of times isolating amplifiers are used in conjunction with other amplifier designs.